So today I thought we'd take a quick look at this Fluke 289. This meter belongs to a colleague at work. Shane brought it to me thinking it might make a good video for me, so he did it thinking about the channel. It's not that he couldn't have done it himself. He just said, have you ever worked on a 289? And actually I haven't. I do have one at work, but I never have had to work on one. I want to mention that if you don't know Shane, he has a channel on YouTube doing PLC and other automation how-to tutorials. He does online PLCsupport.com. And Shane's a colleague of mine and has helped me a lot where we work with automation issues. He's definitely a go-to in that field, and if you hadn't checked out his YouTube channel, I urge you to do so if that's something that interests you, because he's really good at what he does. And I really thank him for thinking about my channel and getting up with me about possibly looking at this meter today. He thought it might make a good video, look inside of it and see what's wrong with it and just how easy it will be to fix. So thanks to Shane for thinking about us on that. So we know that this meter has corrosion, and it's at the point where it broke off the connector at the top on this battery compartment. The meter itself actually looks good, but we'll look inside of it and make sure. We see that the tab is broken off here at the top. So I'm going to see how hard these are to remove. This short one here is actually not in real bad shape. It might be easy to pop out and don't seem too bad. There we go. It does have these little catches where the metal tab kind of grabs, and you can get these for about 16 bucks on eBay, and they're also available on Amazon. I'll have links down in the video description if you're interested in those. So you kind of got to go in and try to push that tab down so it don't dig into the plastic so hard when you go to pull out on it, it looks like. Just trying to pull up here. I'm going to break the tab, but it doesn't matter. This is the one that's already broken. It is moving, but it's digging in. I'm going to have to push that tab down some more probably. Yeah, I thought maybe wiggling it might pop through, pop on out of the plastic and come out. See if I can push that tab down. The screwdriver seems to be getting in there, but maybe not the best. This part of the strip here is popped up. Got that catch right there. I think I'm gonna get something thin. Yeah, this probably will work. Where's my spudger tool? There it is. Let's get these two things out. That might be too thin, but it does get in there easy. This one may even be better to push that little catch or tab in. It is moving a little bit better. This one over here is still catching. There we go, it's moving now. There we go. So if we look at this a little bit closer, she gone. Glad it didn't go too far. If we look at this a little bit closer, we see how they kind of bend that tab out. So it makes a catch. I was trying to push it in there and get in between it and the plastic. We have another one here as well to try to push in. And then maybe we can pry it out. Go ahead and take the strip off so we can get to this better. Yep, see if I can pull right here. There we go. So there we go. You see that tab there where it catches and sticks out. And I got both of those out. I'm going to go ahead and mark where the springs are in case I need to take these contact points out. But what I think I'm going to do, instead of take them out and soak them in vinegar, Since it's got its own little container here, I'm just going to fill it up with white vinegar. We should see the reaction take place here immediately. We do see the fizz in there of where we've seen the heavy corrosion. So I'm just going to let that sit there. I might take a Q-tip here and let's work it in the springs a little bit. And after I go with this a little bit with the Q-tip, we're going to let it set. And while it sets, we'll take a look inside the meter. As mentioned, the contacts look good on the meter itself. But we'll definitely look inside and make sure no battery corrosion is inside. Looks like we got 6 Phillips self-tapping screws here. Nice that Fluke made it where you could get to your fuses without opening up the case. Besides just a battery compartment, that's really neat. After these 6 screws were in just like that. And the contacts are in excellent condition, as well as the board where they make contact, so that's awesome. We got 1 screw here and we can remove our shield. That comes right off, and now we can look at the board better. Looks like our typical Fluke fuses. Our 11 amp. Let's rotate this one to make sure we can see it better. 44 100ths. That's just 10% over the rated for those ranges. Our ceramic laser cut precision networks here. We have one on the lower left here and one up here. We see our input protection. We have our MOVs, NTCs. We see our buzzer. This meter has a really nice buzzer on it. We have our connector for our LCD. It looks like a little flex ribbon cable and connector. Looks like our typical Fluke meter chip set, and also the little SL analog chip on the left here. A better view of our input protection and fuses. And of course we have our super cap up to the right of the buzzer, which is known to be a problem with these meters keeping time when the batteries die. This one, the battery has been out of it for quite some time, so I'm not sure if that super cap's bad or not at this point. Let's go ahead and remove these 4 machine screws for the jacks. We'll move this ribbon cable so I don't damage it. It looks pretty delicate. And let's look at the other side of the board. And here's a little bit better up close look. Our infrared communication LEDs at the top. Below our range switch we do see our bridge rectifier. Not a whole lot else on this side of the board. We have another shield, and then we have our large display, which is cool that Fluke mentions that in the breakdown and has a part number for it. We'll go ahead and put the board back in. Put our LCD flex or ribbon cable back in. Our shield. We'll put the screw back in our shield, as well as our machine screws on the jacks. And there we go. This meter is absolutely mint on the inside. Looks like it's in perfect condition. We'll go ahead and put our 6 self-tapping screws back in. Going to go ahead and get a brush and hit these springs. They're still soaking in the vinegar for now. And while that sets up a little bit more, I'm going to clean the meter up with a wipe. I'll have a link to some similar wipes as well as a lot of items I used here today. If you're interested, it'll be down in the video description. I'm going to use this nice brush to clean up these springs after dumping the vinegar out. This brush has a bristle brush as well as a stainless steel fine brush on one end. I'm going to spray this down with high percentage isopropyl alcohol because we definitely have to clean off all the vinegar or it'll cause a problem with corrosion as well if you leave it. But it really does help with the alkaline leakage. And by the way, if you do need to replace the spring tips, we see they're available as well if needed. They do cost more than the strips I bought, but they are available. I think these are cleaning up okay. You can also buy the whole back battery compartment if needed, but it's over $70, so at least it's available, but it's not the cheap option by any means. So these cleaned up pretty well. Most of them shined up almost good as new. So this is the contact set that I bought, as shown here above, for around $16. As mentioned, you can also get them from Amazon. These are probably going to be a little bit hard to push in since they were definitely difficult to pull out. It's all lining up very well. That looks very promising. Yep, that's sliding in pretty good. A little bit of force needed. Push it down. I'll hold up on that one until we get the other one in. This one should be very easy. This little short one. It was even easy to come out, and it did. It popped right in. Awesome. I'm just going to go around and push this other one fully in. It's sticking up just a little bit. I'm going to go ahead and put the batteries in it, 6 AA's. So we should be getting roughly 9.5 volts or so. And there we go, almost 9.6 volts. And this goes in like so and makes contact. We'll lock the battery compartment in place. We'll power it on. And I did have to set the date and time on this. The batteries have been out so long. But we could have a supercapacitor issue as well. We'll see. So I got a lithium ion cell here. This 4.06 volts. Let's check here in low Z mode is what I like to check the batteries with. Yeah, just 4.1, not a lot of resolution on low Z mode, but it's cool that it does show AC and DC together, and it does give us that low impedance mode. Now if we go up to volts DC, we're gonna see a lot higher resolution. And yeah, 4.0648 NF.Mini Yeah, a lot more resolution. This meter is pretty awesome. So as we see here, we can do several things here. AC plus DC, relative, of course DC mode. I should at least cut the backlight on so you can see that as well. Go to ohms mode here. This thing has an awesome ohms mode and a really cool continuity. I've always liked the continuity on this meter that shows you graphic of your contact making and breaking. On the bottom, that's pretty cool. And like I mentioned, it has a really good buzzer as well. Go to capacitance mode. We have really good ranges here on capacitance, as I'll show up on the top right. Go through some of the ranges here. Has a really good diode mode. You see the resolution on our ohm scale here. It just shows that I have some pretty low quality leads here. You can kind of tell it with this meter. You can also do some recording with this meter. So we'll just look at this briefly. You can do it as a set interval. You can do it as a set duration. So just looking at a duration here and just 4% threshold. I just hit the battery a couple times, but you saw that it had more than that in events because it picked up over 4% of the range with every little minor touch. But that's what our graph shows. At the bottom, it shows where our cursor is at that point in time. One more time here, we'll show it in ohms recording. We'll set it to a duration. Look at the graph here, and you can see this could be handy with maybe monitoring an NTC over time or something that's changing in value. It could be very handy. I'm not going to take a lot of time here on video and make it too much longer, but did at least want to share that because this meter is pretty awesome. Has a lot of cool features. And I have used this meter before to capture a problem, and it was very, very handy. So we could save this, change the name or whatever, and just hit save. And of course you can even take this and transfer the data using the infrared serial cable to your PC if you desire. Another cool thing about this 289, I've always liked the relative function on it. So most high-end meters do have relative where you can like zero out or have a delta between them. But this one takes it a step further with a larger display, and you can see exactly what you zeroed or what the delta is between the two. So that could be very handy as a comparison. You can even go percentage. So on the bench, you know, looking at say 10K resistors, trying to compare which ones are a better match for a circuit, you can actually look at the percentage off from what you have set. So all in all, a very handy meter. So one thing before I go, I want to mention the way the alkalines corrode. I want to see if this will work with the lithium batteries. I have a video talking about lithium batteries and how the voltage is a little bit higher. And so some devices don't like them. I'll have that linked up above as well as at the end of the video. It's not if alkaline's going to leak, you know, it's when. So I do like the lithiums for your higher end, low use devices that may sit in your toolbox or on the bench from time to time. And you kind of forget the alkaline batteries are in there. So just thought I would share that today as well. So I want to thank Shane for giving me this meter and thinking about my channel. And I want to thank you for watching the video today. I hope you liked it. If you did, please like, share, and subscribe. I'm going to have some links down in the video description of the items we used here on this 289, as well as some other items I find very helpful on my workbench. Any of those links you click on are affiliate links, and they help support the channel, and I greatly appreciate it. So thanks so much for watching, and God bless.